form. Sorry. Okay, now the intercepts that it's talking about, when it says intercept form, these are x-intercepts. You know how we've been finding solutions this whole time, estimating solutions? X-intercepts are very related to solutions. More about that after Christmas. Okay, so this is what intercept form of a quadratic equation looks like. You can see that it still has the same a value, which has all of its typical jobs, opening the parabola up if it's positive, or down if the a value is negative, doing the vertical stretching or the vertical compressing. I can't move this, but you can switch to a different seat. I'm sorry, it's in the way. It won't be like this every day. I just need a video for today. Okay. You might notice that if you distributed and did x times x, you would get x squared. So this is a quadratic equation. It's just it's broken apart into factors. This can also be called factored form. Okay. P and Q are going to be solutions or roots. Okay, those two things are synonymous. We list them in curly brackets. So we're going to list the zeros for the graph that's at the right. So I have a solution or a root at negative, what is that, negative 5?
Yeah.
Negative 5, and another one at negative 1. Okay, we're going to find the a value for the parabola. We know that when a is 1, we have the regular pattern 1, 1, 2, 4, 3, 9. But we have to figure out what this parabola is doing. So when we go 1, 2, 3, what is this one doing? Starting at the vertex, right or left 1, going down 1, so down 1. Right or left 2, down, I'm seeing 4 also. Right or left 3, down 9. So what are we multiplying by?
Negative 1.
Correct. Our a has to be negative 1. Okay, so what we found here with the zeros are the P and the Q. So this is the P, this is the Q. It doesn't really matter which one you make which. And we're going to write our equation for the graph in intercept form. So that will be y equals a negative 1. Because it's negative 1, I don't have to write the 1. I'm just going to write the negative. So negative, open parentheses, x minus negative 5, which turns into a
Positive form.
Correct. It turns into a plus addition. Times, open parentheses, x minus negative 1 turns into a positive. That's it. Easy peasy lemon squeezy. I'm going to scoot this up so you guys can see it. Okay, any questions? Okay. So, we are going to practice looking at a table and writing an equation in vertex form on this side and intercept form on this side. And then we're going to rewrite both equations in standard form. So once we convert to standard form, if we've done it right, we should get the same thing on both sides. Okay? Okay. So over here on the left, this is the review. We did this the other day with the table and writing in vertex form from 5.6. So we need how many things for vertex form?
A, H, and K.
A, H, and K. Here, let me go across the top. A, H, oh my gosh. Okay, so looking at my table, what is my jump going from -4 to -3, which is less negative, +1, good. Okay, going from -4 to 0,
+4.
+4. So that pattern is going 1, 1, 2, 4. What must my A value be?
1.
Correct. My A is 1. Oops, I just wrote A. What is my H? Also 1. It's right here. And my K is good. Okay, so vertex form, let's write it out to remind ourselves. It's y equals A times x minus h, quantity squared, plus k. So when I plug my stuff in, I get
Y equals 1 times x plus 1.
Careful.
Minus 1.
Minus 1 again.
Minus 1 squared minus 4.
Good. Okay. We're going to do the other part A, and then we'll do the part B's together. Okay. All right, now we're going to do intercept form. So, what 3 things do we need for intercept form? A,
P
and Q, good. Okay, so my A is still 1.
Mm-hmm.
That's the easy one now. Went from being the hard one to the easy one. What are the P and the Q? And how can I tell?
Would be negative 1, -3. Wait, no, 2 and -3, right?
We're looking for x-intercepts. I have a question for you. Which one of these is, hold on, you're right, but we're going to get there in a second. Okay, which one of these is the y-intercept?
0.
Correct, because it has a 0 for the x. Okay?
Oh, so it's 3 and 0.
Yes, 3, 0 is one of them, and -1, 0 is the other, because they both have 0 for the y value. Okay, that means that they are on the x-axis. Their height is 0, right?
Oh.
So they have to be on the x-axis. That's how you can tell what the x-intercepts are, and that's how you find your P and Q. Everybody okay with that?
Mm-hmm.
Okay, so we're going to make one of them P and one of them Q. It doesn't matter which. Okay, now we're ready to write. Let's write down the form. It goes y equals A times x minus P times x minus Q. Okay, then we plug in all of our stuff. Our A is
1.
1, so I don't have to write it. X minus P, and P is -1. So x minus -1 makes a +1. Good. X minus Q, and Q is 3. So P and Q lie like H. Does everybody see that?
Mm-hmm.
Okay. Okay, now we're going to rewrite our equations from part A in standard form. So for vertex form, first I have to expand and write it twice. So it'll be y equals x minus 1 times itself minus 4. So I get x times x equals x squared. X times -1 gives me -x. -1 times x is -x. And -1 times a -1 gives me a +1. Bring down the -4. Combine my like terms. I get y equals x squared minus 2x. Is that -3?
Yeah.
-3. Bless you. That wasn't a sneeze. I don't know. I guess it was weird to say something. That'll probably still be the least weird thing I do today. All right, you guys ready for the other one? This one's going to be even easier. All right. So do we have to expand anything here?
No.
No, we just get to let her rip. I'm still going to write it once. So it's x plus 1 times x minus 3. So I'm doing x times x,
X squared.
x squared. X times -3.
-3x.
Good. 1 times x.
1x.
Good. And 1 times -3.
-3.
-3. And then I have just one pair of like terms to combine. So -3x plus x gives me -2x minus 3. And they match. Okay. On the back, guys, are review problems that we have already done. We've already talked about. Do you need to see these? Okay. So, okay, cool. Okay, number 2 is just a review problem. We're going to go over some characteristics. So this parabola has a vertex of 2, 3. Okay, it has a max value because it has a highest point instead of a lowest point. So we say at x equals 2, we have a maximum of 3. Okay, the axis of symmetry is the vertical line that chops my parabola in half. Because it's vertical, it'll be an x equals equation. You can see that it's 2 that x equals. So it's x equals 2. The domain for this parabola, because I can trace it without lifting my pencil, it goes forever in both directions, left and right. I can say that the domain is all real numbers. Okay, the range is a little bit different. This parabola opens down. So the range goes from 3, where it's at its maximum, and down. So I can say that my range is y values that are less than or equal to 3. The solutions I'm going to estimate. The solutions come from the x-intercepts. They are the x values of my x-intercepts, and I list them in curly brackets. These are my p and my q. So it looks like about -1/2 and +4.5. Okay, this would be the P, this would be the Q. Actually, it doesn't matter which one's which. Okay, for number 3, we have to estimate the zeros. So we're looking for the P and the Q. We're looking for these 2 points right there and there. They're both negative, so it's not this one. It looks like between -5 and -6 and almost -1. So I'm going to pick this guy right here. Okay. The range. So I look at the maximum, and then I'm going to go down from the max. So y values that are less than or equal to 5. That's this one. All right. For number 4, our options are no real solutions, 1 real solution, or 2 real solutions. We're going to draw pictures of the descriptions and then pick the answers. So we have a graph of a quadratic that opens up and it has its vertex on the x-axis. So vertex on the x-axis and it opens up. I see one real solution because it hits the x-axis one time. Okay, next one. We have a quadratic that opens down, but its vertex is in the second quadrant. So the quadrants go 1, 2, 3, 4. So it starts in the top right corner and it goes around like a C for calculus. So this one has its vertex in the second quadrant and it opens down. So it will cross the x-axis twice, once here and once here. Because obviously I can just extend my x-axis so that it hits that graph. It goes on forever. So we're going to say 2 real solutions. Okie dokie. Now we want a vertex at 0, 3 and opening up. So just be careful where you put the 0, 3. 0, 3 is not here. It's up here. And then we're going to open up. So this one never hits the x-axis, so this one has no real solutions. Okay, that's it.